Hey there guys and gals, it's me nirex and welcome back to Beginner C++ Programming. So now that you guys know what functions are and how we can write and implement them, we're going to talk about a certain group of functions that are, for the right reason, hated by almost everybody, which are called the recursive functions. Now these assholes, believe me, absolutely everybody hates them, and they're just, if you don't hate them, you're kind of weird, okay? Now, I'm pretty sure that when you see how these are implemented, how these work, you're gonna grow a big hatred for them as well. So without further ado, let's get right into it. Now let me just check this little guy right here. Okay, all good. So recursion. Now recursion stands for the function, or the recursion term is called about or is used for functions that call themselves. Now you might ask a question, okay, wouldn't that be stupid? Well, yeah, I don't know which idiot made them, but yeah, that's basically, they're stupid. So what recursive functions look like are like kind of like this. Okay, so I can say something like void foo, like this, foo. So they call themselves within themselves. Alright, now I can do something like std out foo was called. And I can do std end out, just to end the line, go to the next line. And I can now call foo once. What's going to happen is that it's going to go into the function, print this guy out, come down here, call foo, go back into the function, print this guy out, call foo, go back into the function, and it's gonna just repeat that guy over and over again. And as you can see here, the memory just starts going up and up. It's just getting higher and higher until the program crashes. Right? So an unhandled exception at whatever in nx.exe stack overflow. So you may have already seen the website Stack Overflow. The Stack Overflow took its name from kind of a special exception that kind of is thrown when you actually move past the amount of space you have in the stack structure. So as you can see, the memory starts going up and everything just falls apart. And this is what happens. Okay, so we go in, we do that, we call it back and just go back, and the program crashes. Now what recursive functions always must have is a baseline. The baseline is a condition that ends a function. Now how do we end the function? Of course, by a return statement. So they usually have that, and they usually have an iterator. Now let's talk about that. Let me just go ahead and implement a very simple and normal function that we kind of all know. It's called the factorial. Factorial. Yeah, so factorial is written in math with an exclamation mark. So we can say something like 10 factorial, which is a big number, or something else like 4 factorial, 2 factorial, which is 2, 3 factorial, whatever. Now we can do that with recursion. The way we do that is we write something like factorial. Given inputs, we want to calculate the factorial of some number, so that some number should be here. And then, as I already said, we need a baseline. If x is equal to 1, return 1. That is our baseline. When x gets equal to 1, we return 1. When x gets equal to 2, or other than that, if x is not equal to 1, we return the current factorial number times the calculated factorial of the previous number. Okay? So we calculate the factorial of the previous number. How do we do that? Alright, so let's say I want to calculate the factorial of, let's say, 4. Let me just take that away. Alright. So the way it's going to happen is that it's going to take 4. X is going to be equal to 4. We're going to come here. Is x 1? It's not, so we're going to go here. Is x 1? No. Then x is going to... We're going to take 4, which is the current value of x, and times it by the factorial of 3. So we're going to go back in with the x being set to 3. We're going to go here, do 3 times 2, 2 times 1, and 1, which will be automatically returned to us. So we're going to do 4 times 3 times 2 times 1, and we're going to calculate the factorial of 4. And this is basically what Factorial sums up to, or rather recursion sums up to. So whatever function you want to make with recursion or recursive functions, it needs to have a baseline, which is an if statement like this, which returns the function out, doesn't call the function like this here, you know, based on the parameter that, based on the argument value that goes into it, and in the else statement or after the baseline, we just do whatever we do, and that's basically it. And almost always the baseline comes, you know, after or before whatever we do. Always, actually, not almost always. It always comes before the recursion part. Now, I know it's kind of stupid. We don't really need to use that. You could always create whatever you can create with these guys with loops. I can easily create a loop that can calculate the factorial of something for me. Let me actually just do it right now. So we can have an int I, which is equal to the same number. Let me just put it as 4. And we can do while. Let me do something like int result. I can do while I is less than or I is more than 0. We do result times I. What the hell? Result times equals I, and let me just do that to be 1. So that's 1, 2, whatever. And then I plus plus. I can just do it with a simple, easy while. And let's actually test to see if these return the same value. So let me just do int res equals that guy, and std out res std and l and result. Now, res comes from the factorial function that we made. Result comes from the normal while loop that we made. And what the hell? Oh yeah, there we go. So it's 24, and why is it there? So I is, oh, I'm sorry. It should be like this. Yeah, there we go. And there we go. So as you can see, we have 24 for both of them, right? So it both works. Now you could put this guy right here inside another function, but let me just do that right now. Factorial normal int x we do that, and we do return result. So this is the recursive version, and this is the normal version, right? The recursive version, the normal version, and they both give me the same goddamn number. You don't really have to use recursion if you don't want to, and in most cases you really don't want to because they're confusing and, you know, they're shit. But in some cases you might want to. I don't know, I don't really care for them, I don't really give a damn. They're usually used in data structures, and we're going to get to data structures, and we are going to use them, but they don't really have common use. They have special case uses. So that's basically all there is to factorials. And I'm not going to go on and babble more about them. You can learn more about them if you want elsewhere, because I don't really use them all that often, and there's really not much to go on. That's basically all there is to to recursive functions. Now, even though this is absolutely garbage, I'm still going to give you a homework, and we're going to work on that together in the next video. So the homework is, what I want you to do is find the Fibonacci sequence. I'm just going to write it like this. So find the Fibonacci sequence, and let's say like this, the nth element of the Fibonacci sequence with recursion. Or, yeah, with a recursive function. Yeah, that's right. So what I want you to do is write something like this. Int fib, int n, and then do whatever you want here. At the baseline, at the calculation thing and find the nth element of the Fibonacci sequence. And that's basically it. So that's it for this video, guys. Thank you very much for watching. If you have any questions, do ask them in a comment below. And if you really enjoyed this video, leave a like and maybe even subscribe. I would really appreciate it. And I'll see you guys in the next video.